So we're given that M is this matrix here, 2p negative 3q. P and q we're told are integers. If the determinant of M is 13, find an equation connecting p and q. Well, we know that we get the determinant by doing the leading diagonal, so that would be 2q. Take away the other diagonal, negative 3 times p, so that's going to end up being plus 3p, and we know that that determinant is 13. Given also that m squared is this matrix, find a second equation connecting p and q. I think here I might actually just have to do m squared. So I've got 2p negative 3q, 2p negative 3q. So that's going to give me 4 minus 3p, which is this. And then I'm going to get 2p and plus pq. So that's equal to 12. So that will do it. That's the second equation. 2p plus pq is equal to 12. And actually looking at this, I should have spotted that that was the only element that I needed from that matrix. But I'm there now anyway, so that's good. So we can call that equation 1 and we can call that equation 2. And we want to find the value of p and of q. So we need to solve these two equations simultaneously. So I'm going to do a bit of rearranging. That first equation at the top there, I'm going to rewrite that as 3p equals 13 minus 2q. And then I'm going to multiply equation 2 by 3, which will give me 6p plus 3pq equals 36. And then I'm going to substitute. So I've got 6p, and of course I'm actually substituting that 6p as twice 13 minus 2q, because 3p is 13 minus 2q, 6p is twice that. And then I've got 3p, so I replace that with 13 minus 2q, times q equals 36, and I'm hoping that I'm going to get a quadratic equation out of this. So 26 take away 4q plus 13q minus 2q squared equals 36. So a bit of tidying. 26 plus 9q minus 2q squared equals 36. Let's take everything over to this side so that the q squared is positive. Minus 9q and plus 10 is equal to 0. I'm fairly sure we can factorize this. Of course, you can use whatever your favorite factorization method is to get there. I think that if we put 5 here and 2 there and make them both minuses, I think that does it. So that gives me q equals 5 over 2, or q equals 2. So if q equals 5 over 2, we'll get one value of p, and if q is 2, we'll get a different value of p. I think the 2 is the easiest one to do. So 13 take away 4 would be 9, and then divide that by 3, so that would give me p as 3. If q is 5 over 2, 2q is going to end up being 5, so 13 take away 5 is 8, so p would be 8 over 3. Now we were given that p and q were integers, so p equals 3, q equals 2.